Hello everyone, welcome to the next session on algorithmic problem solving. In this session, we would like to look at the following problem. So we are given a matrix which is in row echelon form, and we would like to report the leading element or the pivot element in every row of the matrix. Now let's look at the formal problem definition and also the solution.
The row echelon form of a matrix is a concept used in linear algebra. The leftmost non-zero entry in a row is called its leading entry or pivot. A matrix is in row echelon form if it satisfies the following conditions. 1. All rows which are entirely zeros are at the bottom. 2. The pivot of any row is to the right of the pivots for previous rows. This implies that any pivot has only zeros below in the same column. In this lesson, our goal is to design an algorithm for the following problem. Given a two-dimensional matrix in row echelon form, we need to determine the leading element or pivot for each row. We illustrate a solution idea through the example shown. Given the matrix shown, we start at the top left corner or position 0, 0. The element 5 in position 0, 0 is non-zero. We report 5 as a pivot and move downwards. The element in position 1, 0 is 0, and so we move right. The element in position 1, 1 is 0. So, we move right. The element 4 in position 1, 2 is non-zero. So, we report 4 as a pivot and move downwards. The element 7 in position 2, 2 is non-zero. So, we report 7 as a pivot and move downwards. The element in position 3, 2 is 0. So, we move right. The element in position 3, 3 is 0. So, we move right. The element 1 in position 3, 4 is non-zero. So, we report 1 as a pivot and move downwards. The element in position 4, 4 is 0. So, we move right. The element in position 4, 5 is 0. So, we move right. The element 8 in position 4, 6 is non-zero. So, we report 8 as a pivot and move downwards. The element in position 5, 6 is 0. So, we move right. The element 2 in position 5, 7 is non-zero. So, we report 2 as a pivot and move downwards. The element in position 6, 7 is 0. We need to move right, but that is not possible. At this point, the algorithm terminates. Here we present the pseudocode and Python code snippet for the algorithm illustrated by the previous example. Starting at the top left corner of the two-dimensional matrix, we move right and down according to a couple of simple rules. If we encounter a 0, we move right. If we encounter a non-zero number, we report a pivot. As soon as we have encountered the leftmost non-zero entry in a row, the contents of the rest of the row does not matter. So, after reporting a pivot, we move down. A quick question. What is the running time of the pivot reporting algorithm presented for a matrix with m rows and n columns? Option A, order log n m. Option B, order m plus n. Option C, order m log n plus n log m. Option D, order m plus north whole square. The correct answer is option B, order m plus n. Another question, let it be a matrix in row echelon form. Let us invoke the function ref_quiz. What does the function return? Option A, number of 0 rows. Option B, number of 0 columns. Option C, number of non-zero rows. Option D, number of non-zero columns. The correct answer is option C, number of non-zero rows. Thank you. This course is brought to you by Echelon Technologies.